Hello students, good morning to all. Welcome to your beautiful channel Firjan. Today we discuss series parallel combination of capacitors. How to connect capacitors in series, how to connect capacitors in parallel and related problems we discuss. This belongs to electrostatic potential and capacitance, second lesson 12th standard. It is the 11th video. Previous video we discussed what is parallel capacitors, how to parallel plate capacitors, how to connect charge distribution, that we discussed. So in this one we discuss series combination and parallel combination. See series combination, see here a capacitor. So capacitor means we know already capacitor is the device which stores electrical energy in the form of electric charge. So that is called capacitor. So that capacitor symbol is, it is the symbol of capacitor. Yes na? See variable capacitor na, this is the symbol of variable capacitor. It's not these capacitors means it is a constant, means defined quantity. So these capacitors we connect in series. How to connect na? End to end connection. See, for example, it is the first terminal, it is the second terminal. So second terminal is connected to first terminal of the second capacitor. Second terminal of second capacitor is connected to first terminal of the third capacitor. So it second terminal is connected to negative terminal of the cell. So this combination we call it as series combination. This we call it as end to end connection. See, current is flowing in this way. See here, first one, second one, third one. See, first plate has plus q, second plate has minus q, plus q, minus q, plus q, minus q. Yes now, see here, these are isolated. Minus q plus q cancel, see minus q plus q cancel. See what we get now here, plus q minus q. See here, end to end connection of capacitors we call it as series combination. See, plus q is connected to positive terminal, minus q is connected to negative terminal. This combination we call it as series combination. In series combination, some characters are same. What are that? Now see here, actually capacitance equal to q by v. Yes, now this is the formula for capacitance, charge per volt. See in this one, here potential now v, this one, so we can write here it is v, it is 0. Yes na, see here potential v, here 0. Yes na, see here in this case, when capacitors are connected in series, charge is same, potential is divided. See we can write here, so charge is same, first one, so charge na same throughout the circuit, charge is same, here q, here q, here also q, every point, so charge is same. See second one, potential is different means distributed. How we can say now this one? See here, here charge is q, here charge q, here charge q. See here, q charge is q, capacitance is c1, charge is q, capacitance is c2, charge q, capacitance c3, it is v3, it is v2, it is v1. See here, capacitance na q by v, potential equal to what we can write, q by c. Here c value change, it's not c1, c2, c3, which one is larger? C. V equal to c by v equal to q by c. C larger na potential less, c smaller na potential more. So that's, see here, q v1 equal to q by c1, v2 equal to q by c2, v3 equal to q by c3. So means different capacitance is there, so potential also different. So here what now, this potential v divided into v1, v2, v3. First one v1, v2, v3 means at each capacitor it's divided according to its capacitance. See here what we can write now here, see 3, What is the potential now here? Ratio V1 is to V2 is to V3. We can write here V1 means Q by C1. Yes, Q by C1 is to Q by C2 is to Q by C3. Here see Q common now. See what is the ratio of capacitance now? 1 by C1, 1 by C2, 1 by C3. Potential now V1 is to V2 is to V3. What is the ratio of potential in the series combination of capacitors na? Capacitors V1 is to V2 is to V3. So capacitance now 1 by C1, 1 by C2, 1 by C3. In this one, see total potential here divided here V1, V2, V3 means total potential in the series combination is sum of the individual potentials. See V1 plus V2 plus V3 means total potential in the series combination of capacitors is equal to sum of the individual potentials. See total potential in the circuit in a series combination of capacitors is equal to sum of the individual potentials. V equal to V1 plus V2 plus V3. So here now this, see this combination we get the equivalent circuit. What is now that one? See I write here, see equivalent capacitance. So we can write this one, C equivalence. Yes na? See it is connected to na cell. See it is potential V. So circuit this current is flowing like this. See this equivalence is this one. See this combine we get the equivalent capacitance, that is this potential this one. So this all we can substitute now here. See from this what we can write now here. See V1 equal to what we get here? V1 Q by C1, Q by C1, V2 Q by C2, V3 Q by C3. This we can take equation 1 na. So equivalence, but from this equivalence equation circuit we can take, so V equal to Q by C equivalence. This all values substitute in the above equation. See here for example here above values, above values substitute in equation 1. See here V na Q by C equivalence, I write here Q by C equivalence, that equal to V1 na Q by C1, V2 na Q by C2, V3 na Q by C3. See here Q common na and cancel, what we get na here? See 1 by C equivalence equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is the equivalent capacitance of the capacitors when they are connected in the series combination. Means reciprocal of equivalent capacitance which is equal to reciprocal of sum of individual capacitances, sum of the individual capacitances. See here what we can do now, series combination of capacitors. In this case this we can say end to end connection. Why? Because second terminal of the first capacitor connected to first terminal of the second capacitor, second terminal of the second capacitor is connected to first terminal of the third capacitor. This combination we call it as series combination, that we can say end to end connection. In this case charge is same and potential is different, so means it is distributed. See here charge same na q q q by what is capacitance here? C1. So capacitance q by C2, q by C3. Capacitance different, so potential changes. So which one has more capacitance? That has less potential. Which one has less capacitance? That has more potential. See V equal to what is the formula? Q by C. From that we can write V1 equal to Q by C1, V2 equal to Q by C2, V3 equal to Q by C3. Here see ratio of potentials V1 is to V2 is to V3. See we can write Q by C1, Q by C2, Q by C3. Q cancel, 1 by C1, 1 by C2, 1 by C3. What is the potential ratio of V1, V2, V3? And in terms of capacitance now 1 by C1, 1 by C2, 1 by C3 ratio. Yes na? See what is the potential in the total potential in the circuit V? It is divided at each capacitor. So means total potential in a circuit which is equal to sum of the individual potentials. So this is the sum of the individual potentials. See V equal to V1 plus V2 plus V3. So V1 means Q by C1, V2 equal to Q by C2, V3 equal to Q by C3. So this total equivalent circuit is this one. Why not C equivalence and potential V. So this all will be added now. We get C equivalence, that potential is V. So what now here? So V equal to Q by C equivalence. Why not here? Charge also same here also. So V equal to Q by equivalence. So above value substitute in equation 1. So V1 instead of V1 we can write this one. V2 we can write this one. V3 this one. So V this one. So right now here Q common, cancel. So what we get now, 1 by C equivalence equal to 1 by C1 plus 1 by C2 plus 1 by C3. See here in this one, if see C1 C2 C1 and C2 are in series, what is the shortcut formula now? Here see C equivalence equal to C1 C2 by C1 plus C2, C1 C2 by C1 plus C2. This is the shortcut for when two capacitors are connected in series. So when three capacitors are connected in series now, C1 C2 and C3 now are in series, that case what is the equivalent capacitance now? C1 C2 C3 by C1 C2 plus C2 C3 plus C3 C1. It is the formula for C equivalent. See third one, see if C1 equal to C2 equal to C, then equivalent capacitance now see C by 2. How many here? Two capacitors are connected in series, but they are same magnitude, that case C by 2. For example, n capacitors connected in series, capacitors connected in series, they have same magnitude, that case what is the equivalent capacitance now? N capacitors now we can write C equivalence equal to C by N. C equivalence equal to C by N. So means how many is there? That number we can write denominator, but they are having same magnitude, that case. Yes na? So these are the nodes. See here, C1 C2 are in series. What is the C equivalence? C1 C2 by C1 plus C2. C1 C2 C3 are in series. What is the C equivalence now? C1 C2 C3 by C1 C2 plus C2 C3 plus C3 C1. Yes na? See if C1 equal to C2 equal to C, that case what is the C equivalence now? C by 2. Why? Because here two capacitors are connected in series, they have same magnitude. That case what is the equivalent capacitance now? C by 2. If n capacitors are connected in series, they have same magnitude. Now we can write C equivalence equal to C by n. We can write C by n. So for example, see C1 equal to C2 equal to C3 equal to C4 equal to C is there. That case what is the equivalent capacitance now? C by 4. Why now? 1, 2, 3, 4 capacitors is there. They are connected in series. They have same magnitude. So that is C. That's why we can write C equivalence equal to what? C by 4. This is the shortcut for series combination of capacitors. Yes na? So what is the series combination na? Equivalent capacitance 1 by C equivalence equal to 1 by C1 plus 1 by C2 plus 1 by C3, so on we can write it. Yes na? This is the series combination. Now see, we discuss parallel combination of capacitors. Parallel combination of capacitors. See once here, parallel combination. Parallel combination of capacitors. For example, see here we can take, it is the capacitor, yes, one more capacitor, see one more capacitor, these all terminals, see second terminals are connected to fixed point, first terminals are connected to fixed point, then this combination we call it as parallel combination. See here it is C1 C2 C3 potential V. See here current is flowing from higher to lower. See this one, see Every capacitor has two terminals. It is first to second, first to second, first to second. All seconds are connected to fixed point. All firsts are connected to fixed point. This fixed point is connected to positive one, negative one. So this we call it as parallel combination of capacitors. Parallel combination of capacitors. In this case, what is the total charge now here? Q. See here, total charge in the circuit is Q. Here you see potential now in parallel combination, potential is same. Here potential same, here potential V, here potential V. What we want here? Charge na, actually charge equal to what? C into V, CV. Here see, potential is V, charge is, sorry, capacitance is C1. So C1V, here C2V, here C3V. See here, this means Q1, here Q2, here Q3. Means here Q is divided. In series combination, potential is divided. In parallel combination, charge is divided. So means Q1 equal to C1V, Q2 equal to C2V, Q3 equal to C3V. See, we can write here. See, in parallel combination, potential is same, potential difference is same. What changes now here? Q is different. Q is different means it is distributed. It is distributed. See here, so what now here we can write the ratio q1 is to q2 is to q3. Ratio of charges now at each capacitor is q1 is to q2 is to q3. So that we can write c1v is to c2v is to c3v. V cancel now same. So what we can write? Ratio of capacitance now C1 is to C3, C2 is to C3. See here, when capacitors are connected in parallel combination, potential is same, charge is different, that charge is distributed here Q1, Q2, Q3. So the ratio is Q1 is to Q2 is to Q3. That we can write C1V, C2V, C3V, V cancel, C1 is to C2 is to C3. Yes, now see here in this one, what is the total charge now in the circuit now? Q, capital Q, that will be divided Q1 at C1, Q2 at C2, Q3 at C3. See here, that means total charge equal to sum of the individual charges. So means total charge Q equal to Q1 plus Q2 plus Q3. See, this resultant will be now here like this is there. This is the resultant circuit. See here, potential is V, C equivalence now this one. So potential same, charge only divided. So that charge is here, total charge is Q. Now see here, C equivalence na, I write one by one. So Q1 equal to what? C1V, Q2, C2V, Q3, C3V. It is the charge on each capacitor. See, total charge na Q equal to C equivalence into V. C equivalence into V. This value substitute in equation 1. See, above values substitute in equation 1. We get what now here? Q means C equivalence into V, that equal to Q1 na C1V, Q2 na C2V, C3 na Q3 na C3V. So V common na, so we common and cancel here is there. So what we get now here? C equivalence equal to C1 plus C2 plus C3. This is the equivalent capacitance when capacitors are connected in parallel combination. What is the equivalent capacitance now? Equivalent capacitance equal to sum of the individual capacitances. C equivalence equal to C1 plus C2 plus C3. See here, in parallel combination of capacitors, all the first terminals connected to fixed point, all the second terminals connected to fixed point. This fixed points, one is connected to positive, another is connected to negative. This combination we call it as parallel combination. In this one, potential is difference is same, charge is divided means charge is different means distributed. Here Q1, Q2, Q3. Why now here potential same, capacitance change. So means C1V, C2V, C3V. So means Q1, Q2, Q3. See here, this ratio na Q1 is to Q2 is to Q3. Capacitance na C1 is to C2 is to C3. So total charge equal to sum of the individual charges at each capacitor. So that is Q equal to Q1 plus Q2 plus Q3. Q1 na C1V, Q2 na C2V, Q3 na C3V. See here, equivalence na, this is the equivalent circuit. See here, current is flows from positive to negative. So capacitance is C equivalence, charge is Q, potential is V. So that case, total charge equal to C equivalence into V. So these above values, these values we can substitute in the above equation 1. So we get C equivalence equal to C1 plus C2 plus C3. So this is the parallel combination of capacitors. These related problems we can do now. See, one by one. First problem, see here. First one is 6. First two capacitors are connected in series. See, it is the cell, its potential is 12 volt, it is 6 microfarads, it is 3 microfarads. What we want to find out now? First one, find equivalent capacitance. Find equivalent capacitance, C equivalence. Yes na. Second one, we find what is the charge, charge on each capacitor, charge on each capacitor we want to find out. Third one is, see here, what is the potential difference on each capacitor, each capacitor, so that we want to find out. Fourth one, see here, energy on 3 microfarad capacitor. What is the energy stored on 3 micro capacitor? So that we want to find out. This one we can find out. See here, first what we want to find out? C equivalence. See here, it is C microfarads, 6 microfarads, it is 3 microfarads. So current is moving from positive to negative. In this case, see here, C equivalence, first one we can find out C equivalence. What is the formula for C equivalence? C1 plus, sorry, C equivalence na in series combination. These are connected in series. Series combination na 1 by C equivalence equal to 1 by C1 plus 1 by C2. From this what we can write? 1 by C equivalence equal to, here LCM is C1, C2. It will changes to here cross multiplication here, here means C2 plus C1. So means we can write C equivalence equal to C1 C2 by C1 plus C2. Why not here C? It will changes to numerator. It changes to numerator. It will be denominator. C1 C2 by C1 plus C2. So it is the shortcut for two resistors connected in series case. C1 C2 by C1 plus C2. C1 is what? 6. I write here C equivalence equal to 6 into 3 by 6 plus 3 means 6 into 3 by 6 plus 3 9. Here 3 ones, 3 threes, 3 ones, 3 twos. What we get? C equivalence equal to 2 microfarads. What is the C equivalence na? 3 microfarads. 3 microfarads. See second one. What is the second one? Charge on, sorry, potential on each capacitor. In series combination, potential is same everywhere. So what is the potential on each capacitor? So potential on V1, V equal to what? 12 volts only in series combination. Series combination, potential is same. Yes, now what is the potential on each capacitor? 12 volts in series combination. Why? Because it is same. Third one. See third one now here. What is the, sorry, 1 minute. So potential is not same. In series combination now, what same? Charge only same. Potential is not same. Potential is divided. In series combination, potential is divided, charge is same. Yes na? See here in series combination potential divided, here V1, sorry, here V2. Yes na? See in series combination potential is divided, so before that charge we can write, third one we can write first, charge is same, Q is same in series combination, in series combination. Yes na? See, sorry, what now here C equivalence is 2 microfarads, here charge is same in series combination of capacitors, what divided, potential divided, so we can write now second one. So second one what we can find out, V1. So V1 now what we can write, Q by C1. Q is what, charge na, we want to find out charge first, for that I find out here charge, what is the charge on the circuit na. So charge equal to what, CV, here we can use C equivalence, we can use, yes na. So charge equal to what, C equivalence is 2 microfarads, potential is 12 volt, so means what we get, 24 microcoulombs. This is the charge on each capacitor. What is the charge on each capacitor, Q equal to 24 microcoulombs. Yes na, I will write here, otherwise see charge is same in series combination, so for that charge equal to what is formula na, C equivalence into potential. So charge equal to C equivalence is 2 microfarads into potential is 12 volt. So what we get, charge is 12 to jar 24, 24 microcoulombs. It is the total charge in the circuit. So the charge will be same in the series combination. So what is the charge now? 24 microfarads. Now we can find out third one. So potential we can find out. What is the potential na, potential on each capacitor. So potential formula is V1 equal to Q by C1. So what is Q, here 24, C1 is, what is the capacitance here, first one 6 microfarads, so we can write here 6, 6 ones 6 fours, what is the potential na, 4 volt, so V1 equal to 4 volt. Second one na, see V2 equal to Q by C2. What is Q? Na 24 by C2 na 3. See here 3 ones 3 eights means 8 volts. So means V2 equal to what? 8 volts. Means when capacitors are connected in series combination, charge is same. Potential divided. Potential divided. What is the potential now? V1 4 volt, V2 is 8 volts. Now we want to find out energy on 3 microfarad capacitor. For energy, what is the formula now here? I write here fourth one. So energy equal to what now? Q square by 2C. Here Q now, so 24 microcoulombs. Capacitance now here we can use 3 microfarads. 3 microfarads. See, just we can substitute here. U equal to Q means 24 into 24, capacitance is 3 microfarads. See here 3 ones 3 eights, 2 ones 2 fours, what we get now here, 4 4s are 60, 4 2s are 8, 96 microjoules. What is the energy stored in the 3 microfarads na? 96 microjoules. See once here, it is the series combination of capacitors. When series combination, charge is same, potential is divided, charge is same, potential is divided. In this case what we want to find out first, C equivalence. What is the C equivalence we are getting? 2 microfarads, 2 microfarads. What is the charge on each capacitor na? How to find out C equivalence? C equivalence equal to C1 C2 by C1 plus C2. What is C1? C1 is 6, C2 is 3. Just we can write here, substitute and simplify, we get the answer. So what is the C equivalence? 2 microfarads. Now see here, we want to find out charge on each capacitor. What is the charge on each capacitor? In series combination, charge is same. So Q same in series combination. So Q equal to what? C equivalence into V. C equivalence is what not? 2 microfarads and the potential is 12. 12 to the 24. 24 microfarads. What is the charge on each capacitor? 24 microcoulombs. Microcoulombs. Now see what is the potential on each capacitor? For first one V1, second one V2, third na V1 is 4 volt, V2 is 8 volts. So that we can write. So third one we can write energy stored in 3 microfarads. For that formula is Q square by 2C. Q is 24 microcoulombs. Capacitance is 3 microfarads. Why not C2 we want to find out. They ask particularly what is the energy on 3 microfarads. So we can use this one. So 24 into 24 by 2 into 3, 3 8 jar, 2 ones, 2 fours, 4 into 24 na 96 microjoules. Why? Because here microfarads, sorry, microcoulombs, microcoulomb. Here microfarads, micro cancel. One more micro is there. So 96 microjoules. What is the energy stored in the 3 microfarad capacitor na 96 microjoules. Yes na, this is the solution. Yes na, see we can do next parallel combination. One problem we can do, see parallel combination problem same, but capacitors are different. See in this case parallel combination. See we can take here 3 capacitors, it is one. See another one. Parallel means all the first terminals connected to fixed point and all the second terminal connected to fixed point. So it is connected to positive one and negative one. Yes na, it is parallel combination. Yes na, see here it is 1 microfarad, it is 2 microfarad, it is 3 microfarads. Yes na, capacitance it is 4 volt. See current is flows from higher to lower. In this case here in parallel combination potential is same. Here potential V same, here potential is same. What is the potential here? 4 volt, here also 4 volt, here 4 volt, here 4 volt. What changes? Charge is changes. Here Q charge is there, it divided Q1, Q2 and Q3. Yes na, see here. Now we use this one, we can find the C equivalence first. What is we can find out? C equivalence. See, C equivalence formula is here. In series combination, just we can add C equivalence equal to C1 plus C2. What is C1 plus C2 plus C3? What is here? C1 is 1 microfarad, C2 is 2 microfarads, C3 is 3 microfarads. Just added, now what we get here? 6 microfarads. What is the C equivalence? 6 microfarads. So 6 microfarads. So what is the charge on each capacitor? So charge is different. So first we find out what is the potential on each capacitor. See I write here third one. So potential is same throughout the circuit. What is the potential here? 4 volt. So that's why V equal to what? 4 volt. Potential is 4 volt. Now we can find out second one. So charge on each capacitor. Now C1, it is C1, it is C2, it is C3. So C1, for C1 actually capacitance equal to Q by V. Q by V na capacitance equal to Q by V. Q by V na here C1 we want. So means, sorry, what we want here Q1. So Q1 equal to what? C into V. Charge we want to find out. So Q1 equal to C1V, Q2 equal to C2V, Q3 equal to C3V. Yes na? See Q1 equal to C1 is 1, V is 4. So what we get? 4 microcoulomb. C2 na Q2 equal to C2 is 2 microfarads, potential is 4, 8 microcoulombs. Q3 is here 3 is Q C3 is 3, potential is 4, 12 microcoulombs. What is the charge on each capacitor na? Q1 5 microcoulombs, Q2 8 microcoulombs, Q3 12 microcoulombs. Yes na? See third one. So energy on 1 microfarad we find out here. What is the we want find out? 1 microfarad energy na? So means energy what no formula is here? U equal to Q square by 2C. Here what is the charge on C1? C1 equal to what? Charge on C1 means Q1 4 microcoulombs. Capacitance na C1 equal to 1. Just we can substitute, we get the energy. So energy equal to what now here? Q means 4 into 4 by 2 into capacitance is 1. 2 ones, 2 twos means 8 microjoules. What is the energy stored in 1 microfarad na? 8 microjoules. See here, in parallel combination potential is same, charge is divided. Equivalence na C1 plus C2 plus C3. So what now we can get 6 microfarads. Potential is same na, 4 volt. That is Q1 na C1V, Q2 C2V, Q3 C3V. Just we can write 1 into 4, 4 microcoulombs, 2 into 4, 8 microcoulombs, 3 into 4, 12 microcoulombs. Yes na? See here, this is the solution for second one. See next problem. Third problem, see here. It is 2 microfarads, it is 3 microfarads, it is 4 microfarads, it is 5 microfarads, it is 6 volt. It is the circuit. See here, plus minus. First what we can do now here, which one is series, which one is parallel, that we find out. For that this problem what we want to find out now, find a ratio of charge on 5 microfarads, 5 microfarads and 4 microfarads. So in this one, what is the charge on 5 microfarad? What is the charge on 4 microfarads? That ratio we want to find out. First one we can write here. See, charge now, here Q charge is there. It is here 2 paths is there. This is one path, this is one path. Here it is divided. So means Q1, it is Q2. See here Q2 again same. Here again two paths is there. Here divided. So Q2 can be divided into Q3 and Q4. 2 divided. See again Q3, here Q4, both combine, again come here Q2. See here this Q1, here Q2 combine, again we can get Q. See, this is the charge distribution in the circuit. See once again, here total charge is Q, here two paths is there, here divided, here same charge, here again two paths is there. Here this Q2 can be divided into Q3 and Q4, Q3 here combine, Q4 both combine and come out Q2. Yes now this Q2, this Q1 combine, again charge is Q. Like this charge distribution takes place. Where charge same, that is series combination. Where the charge different, that is parallel combination. Here see Q3, Q4, these two will be parallel combination. Why? Because see these two are different charges is there. So we can solve this one first. I write here, see C equivalence I find out. C equivalence for 2 and 5. C equivalence na, so means parallel combination. So means C1 plus C2 only. Yes na. So we can write 2 plus 5. What we get? 7 microfarads. What is the C equivalence na here? 7 microfarads. I write here circuit. See first 3 microfarads here. This resultant is we can write here. See it is, yes na. See it is connected to circuit. See here plus minus, it is 7 microfarads. C equivalence here I write. C equivalence, this is a parallel combination. It is 3 microfarads. Yes na. It is 4 microfarads. Yes na. It is 6 volt. Potential is 6 volt. Now see here, these two are in series. Why? Because see here Q2, here Q1. Yes na, these two are in series. This case we can write here C equivalence. So what we can write? C equivalence equal to for series combination. See 3 4 means what is the formula? C1 C2 by C1 plus C2. What we can write here? 3 into 7 by 3 plus 7. So what we get? 21 by 10. So means 2.1 microfarads. What is the equivalence now? See equivalence capacitance for these two, 2.1 microfarads. I write the here circuit. See here 3 and 7. What now here? 2.1 microfarad. It is connected to this one. See these two will be 4 microfarads. It is again connected to cell. It is the circuit. So plus minus. See here it is. Yes now here see Q. Here it is Q1, it is Q2, it is Q1. These two are parallel. Why? Because different charge is there. So we can write C equivalence again. So equivalence equal to what? 4 2. So means 2 plus 2.1. 2.1 plus 4 na 6.1 microfarads. Yes na. What is the final equation I write here? 6.1 this one microfarads. It is connected to cell. Yes na, it is plus minus. See it is circuit, finally circuit we are getting. So what is the C equivalent capacitance na? Total circuit 6.1 microfarads. What is the charge? We find out first charge. What is the charge? Charge formula is Q equal to CV. Here we can use C equivalence into potential. What is C equivalence? 6.1. I write here 6.1 into potential is 6, means 36.6 microcoulombs. What is the charge on this one? 36.6 microcoulombs. Now we find out Q1. So Q1, see here it is 6. Here now potential is same here and here. These two are, this is series. This resultant will be parallel to this one. So that is here. These two are parallel. Parallel means here 4 volt. Here potential is same. What is potential? 6 volt. Here potential is 6 volt. So we find out here what is the charge on Q1. I write here Q1. So Q1 equal to what? Q1 equal to capacitance into charge. What is the capacitance? 4 into what is the uh, potential V? 6. Here na 6 na. So 6 4 ja 24 microfarads. What is the microcoulombs? What is the charge on 4 microfarad capacitor na? 24 microcoulombs. 24 microcoulombs. Okay. See, it's one Q1 na 6 into 4 24 microcoulombs. Yes na? Q1 over Q2 we find out. What is Q2? So Q2 equal to what? Capacitance into potential. Yes na? Capacitance is what here? 2.1 into potential is what? 6. So means what we get here? 6 1 6, 6 2 12. 12.6 microcoulombs. 12.6 microcoulombs. See here Q1 equal to 24 microcoulombs, Q2 equal to 12.6 microcoulombs. Now we want to find out here see Q2 same. Yes na? Here in here Q2 same. Why? Because they are in series. So we want to find out potential. What is potential at 3 microfarads? What is potential at 7 microfarads? See, for finding here potential, we can use charge and capacitance. So for that V1, here potential is V1, here potential is V2. For find out V1, here I write V1 equal to what? V1. So means charge capacitance into V1 equal to Q by C1. Q is same. What is Q2? We find out already here 12.6. I write here Q by Q1, Q2 by what we can write now here? Capacitance 3. Yes, now Q2 is what? 12.6. 12.6 by 3. 3 ones, 3 fours, 3 twos. Means what is the V1 now here? 4.2 volt. V1 is 4.2 volts. V2 we want to find out. What is V2 formula? So V2 equal to what now here? See, capac means charge by capacitance. Charge is what? Here and here same. What is the charge? Q2 12.6. 12.6 by capacitance is here 7. So 7 ones 7 8 jar. So means 1.8 volt. What is the potential at V2 now? 1.8 volts. So V2 means here potential is 4.2 volt. Here potential is 1.8 volts. This resultant. So means here these two are parallel now. So parallel means here also 1.8 volts. What we want to find out? What is the charge on 5 microfarad? Charge on 5 microfarad capacitor means what we want to hear? Capacitance equal to Q into V. What is Q here? Q now here how much is there? Here 24 microfarads. We want here charge only, sorry, charge we want to find out. Q equal to C by V. Yes na? C is what here? 5 microfarads. Potential is, sorry, Q equal to CV, not C by V, CV. Charge equal to what? CV. What is capacitance here? 5. Potential is 1.8. See here, Q equal to capacitance is 5, potential is 1.8. Means what here? Q equal to charge on 5 microfarad equal to, I write here 8 15 5 are 90, means 9 micro coulomb. It is the charge on 5 microfarads. Already we find out what is the charge on 4 microfarads, means Q1. Q1 is where? Q1. Yes na? Q1 where we find out, see here, this is the Q1. So what is Q1 now? See, 24 microfarads. These two we want. So means charge on 5 microfarad is 9 microcoulombs. Charge on 4 microfarad is 24 microcoulomb. Their ratio. So means charge on 5 microfarads by charge on 4 microfarads. 4 microfarads. Charge on 5 microfarads is 9 microcoulombs. Charge on 4 microfarads is 24 microfarad coulombs. To microcoulomb cancel, 3 3 jar, 3 8 jar. So means what is the ratio now? 3 by 8 ratio. 3 by 8 ratio. Yes na? So somewhat confusion na? See once again, first here we can divide where charge divided. So where charge divided na, that is parallel, charge same na series. See here Q charge, here two paths is there, Q1, Q2. Here divided charge. Yes na? Again here Q2, here also Q2. Here Q2 is divided Q3 and Q4. Again here Q2 combine and come out Q2. So this Q2, Q1 combine and combine and come out Q. So means this is the charge distribution. See here, this and this different charges, this resultant and this parallel. See here, this resultant and this series. Why? Because here see Q2, here Q2 will come. So this resultant will be series with this one. So this resultant is parallel with this one. So totally we get C equivalence. Yes na? See here, C equivalence. After that we find out what na? What is the charge on 5 microfarads? For that we find out Q1 first. What is Q1? 24 microcoulombs. What is Q2? What now here? 12.6 microcoulombs. Here 12.6. Here totally 12.6. Here divided. Here Q1, Q3, Q4 divided. What is Q3? So we find out now Q3 also. Yeah. Q3 no need, Q4 only we find out. What is Q4? That is this one. So charge on 5 microfarads, 9 microfarads. We can find out here potential. Here potential na 4.2, here potential 1.8, 1.8 volts. Yes na? So by using this potential and capacitance, we find out the what is the charge on this one. Yes na? So this is the solution for this one. Yes na? See, same type of problem, one more we can do, that you have no confusion. Yes na? See once, shall I raise this one? See, Now what is the next one? See here. So this is the question. Here we want to find out what is the energy stored at 1 microfarad. Find energy stored on 1 microfarad. 1 microfarad. See here, for that first we can divide what is the charge. So total charge is q here, it is divided here q1, here q2. Yes na, here see q2 same, here q2 is divided here q3 q4. Yes na, q3 q3 4 combine here, come out with q2. So q2 q1 combine, come out q. Yes na, this is the charge distribution. See here, here this charge is divided, so this resultant and this parallel. Here again charge is divided, so this resultant is with the series, this one, these are parallel. Yes na, these two are series, this resultant and this are series. So now in this one, what is the energy stored on 1 microfarads? For that, what is, for finding energy now we want q and c. C we know, we want to find out what is the charge q4, that we want to find out. Same before, what we can do, like that we can do, and finally we can find the energy. See somewhat small confusion. See here, first we find out in this one, we can combine this one, so we get resultant capacitance. These two are parallel na, so I write here circuit. See this one, yes na, see this combination combine na, so C equivalence I write. So for these two, C equivalence equal to what, this and this combine 5 plus 1, so what we get, 6 microfarads. See here, it is 6 microfarads, so combine we can get. Next see here, yes na, see later, here one more capacitor is there. Yes na, see it is connected to cell. See here 24 micro, sorry 24 volt, here is 4 microfarads, it is 3 microfarads. Yes na, see this combination here, this and this are series combination. This equivalence I write, C equivalence equal to what, 6 means C1 C2 na, C1 C2 by C1 plus C2. I write here 6 into 3, 6 into 3 by 6 plus 3, what we get here, 18 by 9, 9 ones 9 twos, 2 microfarads. So means this resultant is 2 microfarads. I write next circuit. See here, I write now here, see it is 2 microfarads. Yes, it is 4 microfarads. Yes na, so it is connected to cell. See it is 24 volt. Yes na, these two are parallel, so parallel means what, C equivalence I write here, just added 2 plus 4, what we get, 6 microfarads. 6 microfarads. So we want now this resultant is, see this is the resultant 6 microfarads, it is the cell. See now here, what here, 24 volt. So what now here, see we want to find out C equivalence na, C equivalence equal to what, 6 microfarads. Total charge, what is the charge now here, CV na, so 6 into 24. Yes, see 6 4 jar 24, 6 2 jar 12, 12 plus 2, 144 micro coulombs. What is the total charge now here? total charge equal to 144 microcoulombs. We want first here charge, we find out here what is the charge in this one. So total charge is 144 here and here. Potential is same. What is potential here? 24. Here also 24. Means here we find out what is the charge, potential charge on 4 microfarads. See, charge on 4 microfarads. I write here charge on 4 microfarads. See, 4 microfarads. What is the formula? Charge equal to CV na. C is CV. C is what here? 4 microfarads into V is 24. What we get? 4 4 jar 16, 4 2 jar 8, 16 96, 96 microcoulombs. What is the charge now here? 96 microcoulombs. Here charge now, what is the resultant? Here we are getting 2 only. 2 into 2 into 24. What we get now here? 2 into 24. See, so charge on resultant, this resultant what? 2 microfarads, 2 microfarads. So what now here? C is 2, potential is 24. What we get now? 2 4 jar 8, 2 2 jar 4, 48. Yes na. See, 48 microcoulombs. What is the charge on 2 microfarads na? 48 microcoulombs. Here both same charge now. Here we want to find out potential here and here. See, potential now, for that potential at 3 microfarads. Potential at 3 microfarads means potential na q by c. Q same here and here. Charge is what? 48. Yes na. C is what here? 3. See here 3, 3 ones 3 6. What is now here? 16 volt. See, potential at what? 6 microfarads na. See, 6 microfarads. Potential means charge is same. 48 by 6 na. 6 1 6 8 jar 48. So means 8 volts. See here potential at 3 microfarads is 16 volt. Here is potential is 8 volts. 8 volts. See here 8 volts means this also 8 volts, here also 8 volts. Yes na. So that case what we want here? We want to find out potential, we know, charge we know. Charge we find out. What is the charge in q4 now? Charge equal to what? C into V. C is what here? 1. V is 8. We find out now. For charge on q4 charge we want to find out. C V. Yes na. C is what is C? 1. Charge is, sorry, potential is 8. So means 8 means 8 microcoulombs. What is the charge on Q4 na? 8 microcoulombs. We want to find out energy. So energy at 1 microfarads na formula is Q square by 2C. So one energy at 1 microfarad na Q is what? 8. 8 into 8 by 2 into 1. Yes na. 2 ones 2 fours means 8 fours are 36. 36 microjoules. What is the energy stored on 1 microfarads na? What? 36 microjoules. Yes na. It is the answer. Yes na. So what we can do now here? Q1 Q2 we find out, Q3 no need, Q4 we find out. Finally we get the energy stored on 1 microfarads. Yes now this is the process. First we want to find out Q1 Q2 and then here V1 V2. Here V same we can get. So that we can use charge. What is the charge now? V and farads we can use, and charge we find out. What is charge Q4? What is the charge Q4? 8 microcoulombs. See, by using that Q square by 2C. Q na 8 8 by 2 into C. 2 into 1 we can get the charge. Okay. Next. Next problem is, see here, we can, it is the series and parallel combination is there. See, it is the circuit. Here what we find out now, find equivalent capacitance of circuit. So we want to find out equivalent capacitance. First now here we find out which are in series, which are in parallel. See here, for example, here q charge is there, here 2 pass is there, here divided, yes now. So here divided, so this one, so again here it will be divided, so charge will be divided, so here again it will charge divided here, so here also, here and here same charge means series combination. So different charge means parallel combination. These two will be series combination. Before that we can give the values here. It is 2 microfarads. It is also 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 2 microfarads. It is 1 microfarad. It is 1 microfarad. It is 1 microfarad. It is the problem. What is now here? We want to find out equivalent capacitance of the given circuit. See here, here total charge is q. Here two paths is there, this and this. Here charge divided, so q1 plus, for example, here q1, q2. Again this q1 is divided, q3, q4. That q3 is again divided, q5, q6. Here q5 na, here q5. Same charge na, so they are in series. So these two we can solve first. See, they are in series means, series now what is the formula? C equivalence equal to C1 plus C1 C2 by C1 plus C2. Here C 2 2. So means 2 into 2 by 2 plus 2. What we get now here 4 by 4. What we get 1 microfarad. So this resultant I write here. So 1 2 3. This only I write here. See, it is the circuit. See here, this resultant we are getting 1 microfarad. Yes na. See here, it is 1 microfarad again is there. It is 1 microfarad. It is 2 microfarads. It is 2 microfarads. It is 2 microfarads. Here combination is there. Yes na. See, this is the circuit. See here, this resultant is 1 microfarad. I write here 1 microfarad. Sorry, 1 microfarad. One more, 1 microfarad. Yes now this is 1 microfarad. Here one more charge is there, one more capacitor. It is 1 microfarad. Yes now it is 1 microfarad. It is 1 microfarad. See once here, one, this one, this one, this one. So this resultant I write here 1 microfarad. This 1 microfarad again is there. See here, here what q5 charge is there, here q6 is there. Charge is different, so means these two are parallel. So parallel means just added. What is 1 plus 1? 2 we can get. This resultant is, see I write here C equivalence equal to 1 plus 1. So 2 microfarads. 2 microfarads. Now I write here this one, this one, this resultant I write here. What is the 2 microfarads? Already here it is 2 microfarads. It is 2 microfarads. Here 1 microfarad. Yes na, here 1 microfarad. So it is A, it is B. See here it is 2 microfarads. Yes, it is 2 microfarads. It is 1 microfarad. It is 1 microfarad. Yes na, see these two are again series. Why? Because here see, here charge divided, here charge same. So charge same means series. See again I write series na, C1 C2 by C1 plus C2. See 2 into 2 by 2 plus 2. What we get now here 4 by 4, 1 microfarad. Means this resultant is 1 microfarad. I write here, see 1, this is 1. Yes na. See this resultant is here 1 microfarad we get. Yes. See here, sorry, here 1 microfarad is there. Yes na. See here 1 microfarad. Yes na, it is A, it is B. See here, this resultant is 1 microfarad. I write here. Why? Because these two are in series. Is this one? See here it is 1 microfarad. It is 1 microfarad. It is 2 microfarads. It is 2 microfarads. See these two are in parallel. So parallel means just added. So what now? C equivalence equal to C1 plus C2. These two now we get 2 microfarads. So I write here, see now again. So this is 1, it is 1, it is here 2 microfarads, it is 2 microfarads, it is 2 microfarads, it is 1 microfarad. 1 microfarad. These two are again series. Series means C equivalence equal to 2 into 2 by 2 plus 2. So means what we get here, 4 by 4, 1 microfarads. See, these two are series na, we get resultant 1 microfarad. I write here, it is 2, it is 1 microfarad, its resultant is 1 microfarad. Yes na? See, it is A, it is B, it is 2 microfarads. Here see, 1 microfarad, 1 microfarad. Series now 1 plus 1, 2. I write here, what now we get finally? Here 2 microfarads, it is 2 microfarads. Yes, na? It is connected to, it is A point, it is A terminal, B terminal. Now see, these two are in series. So what we can write now here? 2 into 2, C equivalence. 2 plus 2. What we get, 4 by 4? 1 microfarads. What is the C equivalence for this combination? 1 microfarads. 1 microfarads. Once again, listen once. Here see, here q here q divided q2 q3, this q2 again divided q4 q5, q4 again divided q6, sorry q, here see I write here otherwise q, here q1, here q2, here q1 is divided q3 q4, here q3 is divided q5 q6. See here q5 q5 same charge na series combination. Resultant is 1 microfarad. These two removed and add 1 microfarad, 1 microfarad. Here q6, here q5. So both na different charges, so parallel. So parallel means added 1 plus 1, 2 microfarads. This resultant 1 plus 1 not 2, I write this one. So this resultant is series, so that I write 1 microfarad. This resultant is parallel to this one, so I write this one only. See here 1 microfarad, 1 microfarad, 1 microfarad, 2 we get. So this resultant series with this one. See, I write here series with this one. Series na, so C1 C2 by C1 plus C2, 1 microfarad. This resultant is parallel to this one. I write here parallel. So 1 plus 1, 2. I write here 2 microfarads, 2 microfarads. So these two are series. Series means 2 into 2 by 2 plus 2, 1 microfarad. So finally what we get, 1 microfarads. Yes na? See, last problem. See here, it is the last problem in this lecture. See, what is the last problem now? Here see, it is 12 microfarads, that is it is connected to 3 microfarads. Yes, it is connected to 20 microfarads. Yes, it is connected to cell. Yes na? See here, it is connected to cell, so it is plus minus. See, it is again connection is there, it is 2 microfarads, 2 microfarads. Find what is the problem now here, equivalent capacitance, equivalent capacitance we want to find out. See here, we can write here charge is q, here 2 pass is there, here q1, here q2. Yes, now it is coming here, combine again q1 q2, come out. These two are different charges. Different charges means parallel. So we can write C equivalence for these two. So means 3 into 2 by 3 plus 2. Why now here I write, see here, see, C equivalence equal to what now, parallel combination means C1 C2. Sorry, here what we can get, C1 C2 means C1 plus C2. What we get, 2 plus 3, 5 microfarads. See here, different charges now they are in parallel combination. In parallel combination, just added C1 plus C2, 5 microfarads. C equivalence equal to 5 microfarads. I write now again circuit. It is, its resultant is this one. So what now, 5 microfarads. It is 12 microfarads, it is resultant is 5 microfarads, its resultant is 20 microfarads. It is connected to cell, it is positive, it is negative, it is positive, negative. See here, these three are in now series. Why? Because here q charge, here q charge, here q charge. See series na, what is the C equivalence? See 1 by C equivalence equal to 1 by C1 plus 1 by C2 plus 1 by C3. Here C 1 by C equivalence equal to 1 by C1. C1 is 12 plus 1 by 5 plus 1 by 20. We can write LCM na, 12, 5 4 jar, sorry, 5 4 jar 20 or 4 5 jar 4 3 jar. So 5 1 5 1 means what we get now here LCM is, see here, 12, 5, 20, 4 3 jar, 5 like that, 4 5 jar. So 5, 3 sign, 1 1 1. So 5 3 jar, 15, 15 4 jar, 60. LCM is 60. We can take here na LCM 60. See else 1 by C equivalence equal to 1 by 60. Here see 1 by 12. 12 how many times 60? 5 are. So means 5 plus 5, 12 times. So in 12 into 1, 12. 23 times 3 into 1, 3. See we can write 1 by C equivalence equal to what now here 5 plus 12, 17 plus 3. 20 by 60, 0 0 cancel 2 ones means 1 by 3 means C equivalence equal to 3 microfarads. What is the equivalent capacitance of the given circuit now? 3 microfarads. See here we can first charge is where divided, that is parallel, not divided series. According to that we can solve this one. See here q1 q2, these two are parallel. Parallel means just added 2 plus 3 5. See here q, here q, combine na q we can get. So same charge na series. Series na 1 by C equivalence equal to 1 by C1 plus 1 by C2 plus 1 by C3. We can simplify, we get the answer. Yes na, this is the solution. See, so means I think this is very good video. Please see the videos, like and subscribe the channel and share to your friends and relatives. Thank you. Please subscribe my channel.